Graph the equation and label relevant points. If the graph is a hyperbola, show the fundamental rectangle with its corner points labeled, the asymptotes, and the intercepts. We're given the equation y squared over 9 minus x squared over 16 is equal to 1, and we're going to compare our equation to the equation y squared over b squared minus x squared over a squared is equal to 1, and this is the equation of a hyperbola. And because our y squared over b squared term is first, then our hyperbola will have y-intercepts but will not have any x-intercepts. So some points of interest, let's take a look at what a and b would actually be. If a squared is equal to 16, then a will equal plus or minus 4 and b would equal plus or minus 3. And using these values will determine not only the intercepts but also determine where the fundamental rectangle is. So our y-intercepts will occur at 0b and 0 negative b, but I have them both here, so it's 0 3 and also 0 negative 3. So at 0 3 we have a y-intercept, and at 0 negative 3 we have a y-intercept. Now we'll take these values and come up with all 4 corner points of our fundamental rectangle. So again, a would be the x-coordinate, b would be the y-coordinate. We're going to have 4 3, 4 3, and this point was 0 3. This point 0 negative 3. Back to the corner points, we used 4 3. We'll have positive 4 negative 3, positive 4 negative 3, and then we'll go to negative 4 positive 3, negative 4 positive 3, and finally we have negative 4 negative 3, negative 4 negative 3. And those four corner points determine the fundamental rectangle. We'll connect those points with some imaginary lines. There is our fundamental rectangle. And then we'll also draw diagonals actually lines through the corner points, which determine the asymptotes of our hyperbola. So constructing the 2 diagonals, we know that our hyperbola will pass through the intercepts, these 2 y-intercepts, and we also know that the hyperbola will get close to these asymptotes but never cross. So we'll pencil in what the graph would look like, come down, hit this point, get close to the asymptote, not touch. Likewise on the other side and also down below. Hit that point. So there is the graph of our hyperbola.